Wait, stop here. Okay. What happened?
Radiator? What is the
Shafi, why
Yes.
your car is so hot, huh?
I don't know, man.
Is there any problem with your car?
I guess so.
Okay. Wait, Shafi, what's wrong with your car?
I don't know. What happened to my car?
Stop here.
Okay, I will stop here.
I think we need to call a technician to solve this problem. Yeah, I agree with you. Let me call. No? Sekarang.
I think the problem is battery.
I don't know, man.
Let me
What happened?
I don't know. Suddenly our car crash.
Let me see. I think I know the problem.
What is the problem?
I think the problem is your radiator.
Radiator? What is the function of radiator?
Let us explain.
So what is radiator? A vehicle radiator is an essential component of the engine's cooling system, designed to regulate the temperature of the engine and prevent overheating. Modern internal combustion engines generate a lot of heat due to the combustion process and friction. The radiator ensures this heat is effectively dissipated. So how this radiator works? There's 4 types of how radiator works. The first is coolant recirculation. A liquid coolant, a mixture of water and antifreeze, absorbs heat from the engine as it flows through passages in the engine block and cylinder head. The heated coolant exits then the engine and enters the radiator. Second is heat dissipation. The radiator consists of a series of thin tubes and fins that provide a large surface area for heat exchange. As the coolant flows through these tubes, the heat it carries is transferred to the radiator metal surface. And the third is airflow cooling. Airflows over the radiator fins either from the vehicle motion, natural airflow, or a cooling fan. The moving air carries away the heat, cooling the coolant inside. And the final one, the fourth, is recirculation. The now cool coolant exits the radiator and is pumped back into the engine by the water pump to repeat the process.
For the next part, we will talking about the important part and the key component in the radiator. In this part, we will discuss on why do we need a radiator in car and how radiator keeps an optimal temperature in the engine. Also, we will discuss on what is the key component in car radiator. Okay, first we will talk about why do we need a radiator in car. The combustion of fuel in the engine produces a large amount of heat. The chemical reaction between the fuel and oxygen releases the energy. So this heat must be managed to prevent the engine from overheating. Therefore, a cooling engine system is required in the car. That's why the radiator was invented. Next, how radiator keeps an optimal temperature in the car. There are 2 processes that ensure the engine has an optimal thermal to operate, which are first, the phase changes. Phase changes happens due to the antifreeze in a coolant that circulates through the engine. Antifreeze lowers the freezing point and raises the boiling point of the coolant. This ensures the coolant remains in the liquid state across a wide temperature range, improving heat transfer efficiency. Next, energy conservation. The radiator ensures efficient energy transfer by following the laws of thermodynamics. It prevents energy loss and ensures the engine operates within optimal thermal conditions. Usually, the extreme weather like winter or summer can affect the engine. Therefore, it has to keep it warm with the help of component called thermostat. Next, key component in the car radiator. There are many important parts in the car radiator. However, let's look at the component that plays a crucial role in the radiator. Thermostat. Thermostat is a valve that regulates coolant flow based on engine temperature. It remains closed when the engine is cold and opens as the engine heats up. The thermostat monitors the engine's temperature. It stays closed when the engine is cold, allowing the engine to warm up quickly. Once the engine reaches the optimal operating temperature, the thermostat opens to allow coolant to flow through the radiator for heat dissipation. The thermostat contains a temperature-sensitive wax pellet. When the engine heats up, the wax inside the thermostat melts and expands. This expansion pushes a piston that opens the valve, allowing coolant to flow. The thermostat regulates depending on when and how much the heat is transferred from the engine to the radiator. This ensures the energy conservation and prevents overheating. Okay, a closed thermostat happens to keep coolants in the engine to allow it to warm up faster, reducing fuel consumption and emissions. Where open thermostat happens to direct coolant to the radiator to release excess heat, maintaining the engine within safe temperature limits. In summary, during cold weather, the thermostat stays closed longer to help the engine warm up efficiently. It only opens when the engine's temperature reaches the threshold for safe and optimal operation.
Next, we move on to the next part. This is the component of radiator. Each component is vital to ensure the radiator works properly. Furthermore, this is the car cooling system. The coolant water will be cooled by the airflow and the fans, and the pump will circulate water through jacket to cooling the cylinders and cool down the engine. The thermostat regulates flow of the water. Radiator will be analyzed as an open system. The mass is crossing the boundaries of the system and going into the air. In open system, mass can cross the boundaries, but in closed system, there is no transfer of mass. An open system in a radiator refers to a cooling system where the coolant is exposed to the atmosphere. Moreover, what is coolant water? Coolant water is a liquid used to control temperature by absorbing heat and preventing engines or machines from overheating or freezing. It often contains water mixed with chemicals to protect against extreme temperature and corrosion. Importance of cooling water: heat absorption and transfer, prevention of overheating, good boiling point and freezing point. Why do we need to use coolant water than regular water? Coolant water has a high boiling point and a very low freezing point than regular water. Next, this is the application of radiator. Firstly, we have radiator in CPU to make sure the computer temperature was maintained. Next, we have radiator in car engine and heavy buildings and heavy machines. Thirdly, we have medical industry. Radiator is used in MRI machines. Lastly, we have radiator that used in residential buildings that has 4 seasons.
Last but not least, this is advantages of radiator. The first one is efficient heat transfer. Radiator use thermal conduction and convection for heat transfer. The metallic structure often made of material like cast iron or aluminium. It allows efficient conduction of thermal energy. Next is high specific heat capacity. Water used in most radiator. It has a high specific heat capacity, enabling it to store and transfer significant amounts of heat without rapid temperature loss. Next, stable thermal energy source. Radiators rely on phase stability. Water remains in the liquid phase under typical operating temperatures, ensuring consistent thermal energy delivery. Last of advantages of radiator, energy conservation. It is modern radiator system utilize energy efficient design like thermostatic valves, minimizing energy waste through controlled heat release. Next, disadvantages of radiator. The first one is thermal lag. Radiator depend on heat transfer, on conduction and convection, which is slower compared to radiation like infrared system. This creates a delay in heating. Next, corrosion and scaling. Metal radiators may undergo oxidation or corrosion, particularly if exposed to oxygen or impurities in water. Hot water can cause scaling due to precipitation of salts like calcium carbonate. Next is heat loss. Heat energy can dissipate into the surrounding during transfer, leading to thermal inefficiency, especially in poorly insulated environment. Last one is environmental impact. If radiator rely on fossil fuel-based boiler, they contribute to carbon dioxide emission and exacerbate the greenhouse effect.
For my part, I will share the conclusion about the radiator. Basically, the thermochemistry play a key role in the functioning of radiators by describing the heat energy of transfer process. Radiators work by converting thermal energy into heat, which they transfer into the surrounding air. In a typical radiator, hot water or steam circulate through metal pipes or fins, which have a high thermal conductivity. The metal absorbs the heat, and due to the principle of thermochemistry, the heat energy separates from the hotter surface to the cooler air around it through condition, convection, and radiation. This transfer of heat warms the room effectively. Understanding the thermochemistry allows engineers to design radiators that maximize heat transfer, improves energy efficiency, and maintain consistent room temperature. Don't forget to always check the condition of your radiator to prevent accident from happening. Thank you. A good radiator make your ride smoother.